This is Module 16, Lesson 2. Today we're going to look at calculating pH and pOH. We have already talked about the definition of what makes an acid and what makes a base, so now we need to look at how do we define that in terms of its strength. So, first of all, let's talk about the pH scale. Right here you have some definitions and some of it's just random knowledge that you need to know about this. All right, so as far as the pH scale goes, you will not be given an image like this on the NC final exam. It's up to you to understand the scale. You do not need to know all of these. These are merely examples that you might find interesting. You do need to know that neutral is 7. So if you have a pH of 7, you have a neutral solution. A neutral solution is where the concentration basically of the H pluses and the concentration of the OH minuses, they're equal in amounts. And if you add together an H plus and an OH minus, what that gives you is HOH. And another way of looking at HOH is H2O. It gives you water. That's why it's neutral. Now, if you go anything below a 7, I don't care if it's 6.999, you have an acidic solution. So acids are below 7, and then basic is anything above 7. Neutral is exactly 7. Now, you can see some examples down here of different types of things and where they fall on the pH scale. Another thing that you need to know is that the word alkaline means basic. So if you see that a solution is alkaline, that's another way of saying that. And the other random fact is that this pH scale is based on powers of 10. So if you go from a pH of a 1 to a pH of a 2, that is not 2 times stronger. That is actually 10 times stronger or weaker, depending on which way you're going. If you're going from 1 to 2, it's 10 times weaker. And if you're going from 2 to 1, it's 10 times stronger. So if you go from 1 to 3, that's 10, and another 10, that is 10 times 10. That is 100 times stronger or weaker based upon your perspective. So do not look at it as a 4 is just 4 times stronger than a 1 or 4 times weaker than a 1. Absolutely not. That would be 10 times 10 times 10. That'd be 1,000 times. Okay. Let's look a little bit further at this idea of the OH minuses and the H pluses. Right here we have our traditional pH scale. This is how you were used to seeing it. You were taught starting probably back in late elementary school about pH, about how 7 was neutral, and below 7 you had your acids, remember? And then over here we have base. Well, we're going to look at something called pOH. And if you can tell by looking at the little chart here, they're opposites of each other. Now this is still acidic. It's still an acid if you're on this end of it, and it's still a base if you're on this end of it, but the numbers are backwards to each other. So if you have a pH of 7, you'll also have a pOH of 7. But if you have a pH of 2, you're going to have a pOH of 12. We're going to see a formula here in just a minute that will tell us that if you add together the pH and the pOH, it will add up to 14. And look at it right now. It's totally true. 0 plus 14 is 14. 1 plus 3 is 14. 2 plus 12 is 14. 3 plus 11 is 14. Like, it works the whole way down. Remember on the slide before we were saying that if you have an acid, what's happening is that the concentration of OH is increasing. So down here we have actually, and I think I just said OH, if you have an acid, your H pluses, the concentration of H pluses is very high. And down here, the concentration of OH minuses is very high. So when you have a base, you have a lot of OH minus. And when you have an acid, you have a lot of H plus. And what happens here in the middle is that the H pluses equal the OH minuses right here at 7. So, there's a gradual changeover in the two of these things, okay? Now, we're going to actually calculate these things. And so I have the formulas. They're all right here, but they're all also on your reference table. And that's what I wanted to point out right here, is that these formulas are all present right here. It's the last 5 formulas. Oops, sorry. It's the last 6 formulas. Just kidding. It's the last 6 formulas. I tried to leave one off there. So we have 6 formulas to work with. We have looked at all of the rest of these. This is page 3 of your reference table. You will have these on the final exam, which means that you do not need to memorize any of these. You, however, do need to know that they're here and how to use them. So when we talk about pH and we say that something has a pH of 7, how we get pH is it is a mathematical formula. It is the negative log of the concentration of the H plus ions. Likewise, if we have pOH, the P stands for the negative log. So it's the negative log of the OH minus ions. Right here is what we already said before. This comes in handy, that if we do the pH or the pOH, they both add up to 14. So if we're given one, we should be able to figure out the other. The purpose of these two equations is to figure it backwards. It's basically to do this. If we're given the pH, if I know that something has a pH of 8, and I want to solve right here for the concentration of the H pluses, how do I solve for X? The easiest way is to follow this equation. We just do 10 to the negative pH. On your calculator, if you want to do the inverse log and you understand how to do that from your math classes, it's the same exact idea. As long as you end up with the right answer and you know what to do, that's what matters. I'm going to work my problems according to these two formulas since it's what's on our reference table. And then we have one last formula that, I'll be honest, I do not usually use this formula. It is absolutely not necessary given these other ones. So, I'll show you where it could be used here in a minute, but it's not, it could save you a little work, I suppose. But, usually I just choose to go with the other ones that I've already got. But all it's showing me is that the concentration of the H's times the concentration of the OH minuses is 10 to the negative 14th. So if it asked me basically for one of these without giving me if it didn't give me the pH, it gave me the pOH, but it wants me to find this, I could use this formula to work backwards. So what we're going to do now is we're going to do some sample problems with these and show you how it works. Before we go, I'm sure you would love a new rule with sig figs. That's said with complete and total sarcasm on my part. Sig figs are done a little differently with pH simply because the numbers go from 0 to 14. So remember we just said that there's a 10-fold difference in pHs. So if we go from if I have a pH that's supposed to be 13 and we knock it down to a pH of 10 because it needs to have one sig fig. The problem with that is I'm not off by just 3. I'm actually going to be off by we'll go to 12, 11, and I'm going to be off by a factor of 1,000. So that's a really big deal. So with sig figs, what we assume is that you have to have everything to the left of the decimal place. All of that stays, and the sig figs are shown with the number of decimal places that you have. So if I have a pH of 13.0, what that tells me is it had one sig fig. The concentration had one sig fig. If I have a pH of 13.01, that right there has 2 digits to the right of the decimal. That tells me that my concentration had 2 sig figs. So we use the decimal places to represent the sig figs. Why does this matter? Well, because when you take the quiz online and you're having to put your answers in, you need to give it with the proper number of sig figs for the fill in the blanks, or you're not going to get the right answer. So you now need to have your practice sheet because I'm going to do the examples at the top. Oops, just kidding. Not quite ready for that. I forgot that I had this in here. The definitions of a strong acid and a weak acid or base. Basically, strength is about how completely they ionize in solution. We have talked about this before with solutions and with the breaking apart of things in net ionic equations. That if you have something, remember when we talked about electrolytes? Strong electrolytes broke apart completely and weak electrolytes broke apart only a little. Well, it works the same way with acids and bases, and acids and bases are electrolytes. They work really well to conduct electricity, so it's the same way with electrolytes. They're strong if they fall apart completely, and they're weak if they break apart just a little. Now, I do want to point out that concentration and strength are not the same thing, and we use the word strength in everyday life as if we mean concentrated. So if somebody makes coffee and they make it too dark, you don't like the taste of it, what you'll say is it's too strong, but what you really mean is that it's too concentrated. Strength and concentrated with acids and bases are different. Concentration is how much acid or base you have in solution compared to the water, and strength is about how much it dissociates or ionizes, how much it falls apart. So, for example, you have hydrochloric acid in your belly, and it is a very strong acid. It dissociates completely, but it is not concentrated, or it would eat a hole straight through your stomach. So strong does not necessarily mean concentrated. You can have strong and concentrated, or you can have strong and dilute. You can have, weak and concentrated, or weak and dilute. It's not the same. Now it's time for practice problems. Okay, so your first one says, what is the pH of a solution if the H plus concentration is this? So all we're going to do, if they're asking me for the pH, my pH equation is the negative log of the concentration of the H pluses. So we're going to take this number, and in your calculator, you're going to type negative log. The log button on your calculator, here's your screen, is usually up here in this area of the upper left-hand corner of the keys on graphing calculators and on scientific calculators. It's the negative log of 7.2 times 10 to the negative 9th. Now, take a moment to put that in your calculator and make sure that you get what I'm going to put on my paper, on my screen here. Oh, and I forget that when I dot real fast, it does this. So, my calculator screen shows 8.1426 and some change. So if you got that, you did the steps correctly. Don't forget the negative. The purpose of the negative is that if it's not there, then this is a negative, and we don't have negative pHs. So it's there to make it a positive pH. Okay, now let's talk sig figs. Look up here. This had 2. It has 2 digits in it. There's 2 sig figs in this. If you can see my shading right there, there's 2. So we can keep 2 decimal places. We're going to call our answer 8.14. Because remember, our number of decimal places is our sig figs. So the pH of this thing is 8.14. Now, what about the pOH? Well, I have a formula for pOH. The formula for pOH is that it is the negative log of the concentration of OH minus ions. So we have the concentration of that. We can just plug it in. It's the negative log of 3.5 times 10 to the negative 2nd, according to this up here. So again, pause the video, see if you can put this in your calculator and get the same thing that I do. And if you really want to go for broke, go ahead and round it based on sig figs before you come back so you can see if you get the same answer that I do. So here's what I get. I get 1.4559 and some change, and a page change. So in terms of sig figs, this has 2 sig figs. I can keep these 2 digits, so my answer will be 1.46. My pOH is 1.46. Okay, what about this one? What's the pH that has what is the pOH of a solution that has a pH of 3.14? So if you get ready to do what we did last time, and you jot this down, and, brackets, and you get ready to do the concentration of this, well, this is missing, so I can't use this. But I have that other equation that says the pH plus the pOH adds up to 14. Well, I could plug that in here. If the pH is 3.4, then all I need to do is solve for the pOH. So subtract 3.4 from both sides, and I will get 10.6. Now, we keep whatever decimal places that we had before. This had 1 decimal place, so we're going to keep 1 decimal place because, I mean, we assume that this 14 is, it has an infinite number of sig figs after it. So now let's try a different problem. Where did my mouse go here? Okay, so what about these? This time we're still going to have to use these skills, but it says classify it as acidic, basic, or neutral. Well, there's one of 2 ways to do this. We can classify something as an acid, a base, or neutral based upon either the pH scale or the pOH scale. I prefer to use the pH scale that runs from 0 to 14, which means in order to do this, I need to find the pH. So your first step with each of these is going to be find the pH, and then we'll decide where it falls on the pH scale. So for the first one, they give me the concentration of H pluses. So then the easiest way to find pH for this one would be to put it in to the pH equation. Plug this number in right here, and let's do some math. So if you want to, pause it and work ahead of me. If you want to, you can pause it. If you think you've got this, go ahead and work ahead of me for the rest of these and then come back and check your answers. You can use the video to skip it. So I get that the pH is 8.60 ... however many. Now, I didn't round this because I'm not finding the pH. I'm just deciding if it's an acid, a base, or neutral. If it's an 8 point something, then it is above a 7, which makes this thing a base. It is an alkaline solution. Okay, this one gives me the pOH. Well, don't just go, hey, 12 is basic. You can answer this one of two ways. You can answer it with the knowledge that pOH is backwards. So if this is, it looks like a base, then it's really going to be an acid. Or you could put it to some math here, that the pH plus the pOH is 14. So if the pH if the pOH is 12, that means my pH is going to be 2. Well, 2 is way down here, so we have just proven that this is an acid. Okay, what about this one? Now, this one's going to be a little more involved stepwise, because I either need to calculate the pH or I need to find the pOH and then find the pH. I mean, there's a couple of different ways to go about it. My choice was to put it into the pOH equation and do the negative log of the 9.8 times 10 to the negative 11th. And I got that that was a pOH of this. Okay. Then I did 14 minus that number in my calculator to get basically a pH of roughly 4. And if it has a pH of 4, then that makes this one be an acid. Now, did I have to go this extra step right here? No, I didn't. I could have stopped here and thought to myself, this is pOH. If it was pH, it would be a base. So since it's pOH, it's backwards. It'll be an acid. It's on the opposite end of the spectrum. This one, I don't have to do anything. It gives me pH, and that is very acidic because it is way down here close to 0. So sometimes they might be that simple. And then I have a few more just in case you're wanting some more practice. I have 3 more problems. These were all calculate the pH. So on this one, very simple. They give me the concentration of OH, so I just plug that in to this. Now, if I could teach you a trick, it would be this. If you're asked to find the pH and it's a 1, then the pH is whatever the power is. So if it's 1 times 10 to the negative 5th, the pH is going to be 5. If it's 1 times 10 to the negative 11th, the pH will be 11. But this number up front has to be a 1. It can't be anything else, and not 1 and like 1.2 doesn't work. Just 1 times 10 to a negative power, make the pH the power. Okay, on this one, let me show you 2 different ways that you could do this one, and you choose the path that you like the most. Way 1 is use what we've already been working with. If I'm wanting the pH, the first thing that I could do is I could find the pOH. That is going to be the negative log of 2.2 times 10 to the negative 7th. And I got that that was a pH of roughly 6.657. I can't remember if there were more digits or not. I didn't write ... So then I used the knowledge that pH and pOH together add up to 14 to subtract and find that my pH is 7.34 with proper sig figs, 2 sig figs because this has 2 sig figs. The other way is using your reference table. You see that Kw is equal to the concentration of H plus times the concentration of OH minus, and that equals 1 times 10 to the negative 14th. I could plug it in here. I'm hunting this one. It's 2.2 times 10 to the negative 7th, and that equals 1 times 10 to the negative 14th. So in your calculator, you divide both sides by the 2.2 times 10 to the negative 7th, if I can fit it over there, and you will get that the H pluses equals, honestly, I don't know what that was. I didn't write it down. You'll get that the H pluses equals something, and without a calculator, I'm not sure the number. And then we put that into the negative log of whatever number we get up here goes in, and you'll find it. But to me, like, this is a whole lot of work. This is a whole lot less work, so I much prefer method number 1. Now, if you were looking for the concentration of the H pluses, this would probably be your shorter route, is just to go this way. Now, this one, ask me to do the pH of this one. It's real simple, then we're just going to subtract. 14 minus 1.4 is 12.4. So, it's practice time. Now, one of the things that I did on your practice that I didn't include any examples of is if it asks you to find the concentration of H pluses if you have a pH of, 13.32, then you use the formula on your paper that says it's 10 to the negative pH. So what you put in your calculator is 10 to the negative 13.32. And literally on your calculator screen, you can equal 10, and then the caret button, it's got the little up arrow, negative 13.32, like 10, up arrow, negative 13.32, hit equal, and you will get the correct answer. Like you'll get some sort of a decimal number, most likely with a power of a pretty big negative power of 10, like 10 to the negative 14th or something, okay? You just work backwards. So if you need help with these, you can let me know during office hours. Otherwise, they should be kind of self-explanatory. I did not put answers on there for this, so if you're in doubt, then check in with me earlier than the due date so that I can help you know if you are correct or not.